Good morning, everybody. Welcome to my channel Proper Guidance. Here we are to discuss about Introduction to Problem Solving. We have already discussed this chapter. Part 1 has been discussed. Okay. There we know about the following steps like steps of problem solving, analyzing the problem, developing an algorithm, coding, testing and debugging. Okay. All these things. For today's class, I will start from algorithm part. Okay, so let's start for today's class. Just sincerely listen to this. Okay, so today's topic is algorithm. Look, what is algorithm? In our day to day life, we perform so many activities, right? For example, suppose you have to go to school. What are your preliminary task? You have to get ready for school, making breakfast, riding a bicycle or any vehicle, wearing a tie, solving a puzzle, and so on. To complete each activity, we follow a sequence of steps, right? Suppose following are the steps required for an activity riding a bicycle. What are the following steps for riding a bicycle? These steps are for riding a bicycle. This is very simple and easy, right? Remove the bicycle from the stand, sit on the seat of the bicycle, start pedaling, use brakes whenever needed, and stop on reaching the destination, right? So, algorithm is nothing but some steps to do some activity properly. That is called algorithm. Now, why you use algorithm? Why do we need an algorithm? This is the main question of this chapter. Why do we need an algorithm? Right. A programmer writes a program to instruct the computer to do a certain task as desired. Right. The computer then follows the steps written in the program code. Therefore, the programmer first prepares a roadmap. The programmer first prepares a roadmap of the program to be written before actually writing the code. And this particular thing is known as an algorithm. This is not actually the programming code, this is just written in plain paper to prepare a roadmap of the program, and that is nothing but the algorithm. Look here, such a roadmap is nothing but the algorithm, which is the building block of a computer program. This is the main definition of an algorithm, that such a roadmap is nothing but the algorithm, which is the building block of a computer program. For example, suppose searching using a search engine, sending a message, finding a word in a document, booking a taxi through an app, performing online banking, playing computer games, all are based on algorithms. Writing an algorithm is mostly considered as a first step to programming. So, to learn any programming language, you have to first learn about algorithm. Without writing an algorithm, this is very ambiguous to solve a problem. Once we have an algorithm to solve a problem, we can write the computer program for giving instructions to the computer in high level language. If the algorithm is correct, computer will run the program correctly every time. So the purpose of the using an algorithm is to increase the reliability, accuracy, and efficiency of obtaining the solutions. Right. So this is clear to you what is an algorithm and why do we need an algorithm. Okay. Now see here. Here is an example for an algorithm. Let us now find the greatest common divisor of two numbers 45 and 56. So GCD, what is GCD? GCD is the largest number that divides both the numbers, given numbers. Now find the numbers which can divide the given numbers. So first of all we will Find divisors of 45 and divisors of 54. This is the first step. Divisor of 45 and divisor of 54. This is the first step, and then we will get this thing. Step 2, then find the largest common number from this section. That is this one. GCD of 45 and 54 is 9. Hence, it is clear that we need to follow a sequence of steps, right? We need to follow a sequence of steps to accomplish the task. Such a finite sequence of steps required to get the desired output is called an algorithm, right? It will lead to be the desired result in a finite amount of time if followed correctly. So algorithm has a definite beginning and a definite end and consists of a finite number of steps. This is very important, that algorithm has some finite number of steps. So this is all about introductory part of an algorithm. I hope you can understand it properly. And now see characteristics of a good algorithm. What are the characteristics of a good algorithm? Uh, in the previous class, we have already discussed that any problem may have more than one algorithm. Now you have to choose the right algorithm. So how can we understand that algorithm is the good one? So you have to go through this point, characteristics of a good algorithm. First point is precision. Now what is precision? The steps are precisely stated or defined. Means it will be defined elaborately. Elaborately. Now uniqueness. Results of each step are uniquely defined and only depend on the input and the result of the preceding steps. Then comes finiteness. What is finiteness? The algorithm always stops after a finite number of steps. It should have finite number of steps. Then we can say that the algorithm is a good one. And input means the algorithm, look here, the algorithm receives some input, and output means the algorithm produces some output. So these are the basic characteristics of a good algorithm: precision, uniqueness, finiteness, input and output. Now see here, while writing an algorithm, it is required to clearly identify the following also. What are those? Those are the input to be taken from the user, processing or computation to be performed to get the desired result, and the output desired by the user, and the output desired by the user. Okay, these points are very important point. So just go through it properly. If you have any query about this point, please comment me. I will definitely clear your doubts. Now we will see how to represent an algorithm. Representation of algorithms. Using their algorithmic thinking skills, the software designers or programs analyze the problem and identify the logical steps that need to be followed to reach a solution. Once the steps are identified, the need is to write down the steps along with the required input and desired output. There are two common methods of representing an algorithm. This is the main thing of this topic, that there are two common methods of the representing an algorithm. First one is flowchart and second one is pseudocode. Either of the methods can be used to represent an algorithm while keeping in mind the following. It showcases the logic of the problem solution, excluding any implementational details. It clearly reveals the flow of control during execution of the program. Flowchart. Now, what is flowchart? Flowchart is nothing but a representation of an algorithm. Now we will learn about flowchart. This is very important to learn any programming language. Before learning any programming language, you should have the complete concept of flowchart algorithm. These are very important for solving any problem. So here it is, the flowchart, visual representation of algorithm. What is flowchart? A flowchart is a visual representation of an algorithm. A flowchart is a diagram made up of boxes, diamonds, and other shapes connected by arrows. Each step represents a step of the solution process, and the arrow represents the order or link among the steps, right? So here it is. Look, uh, I think everybody can see this picture here. This is the diagram about flowchart. Here are some symbols. Flowchart symbol is here, and their functions are written here, and the description is here. Now see the first symbol. You can see it, the oval one. This is used for start or end, also called terminator symbol. It indicates where the flow starts or ends. The same symbol is used as terminator, either it is start or is it at the end point. Okay. Then comes the rectangular shape. This is known as process, also called an action symbol. It represents a process, action, or a single step. And then comes decision. This box is decision. A decision or branching point, usually a yes, no, or true or false question is asked, and based on the answer, the path gets split into two branches. Then comes this parallelogram, input or output, also called data symbol. This is known as data symbol. This parallelogram shape is used to input or output data, and arrow connectors to show order of flow between shapes. Okay, now write an algorithm to write an algorithm. Just wait. I just mark it. A flow chart is a visual representation of these things and this and that steps. Steps are here, and up to this one. Just wait. Okay, and now see here, write an algorithm to find the square of a number. Now we have to solve a problem, and for this we have to write down an algorithm for it. What is the problem? Write an algorithm to find the square of a number. Now, before developing the algorithm, let us first identify the input, process, and output. What is the input will be? Here input will be number whose square is required, right? We have to take any number, and then we have to calculate the square of that particular number. This is the problem. So for algorithm we have to just write down the steps. First of all, the input, then it comes about the process. What is the process? Multiply the number by itself to get its square. Square means multiply the number by itself to get its square, right? Then comes the output section. What will be the output? Square of that particular number. Now algorithm to find square of a number. What will be the actual algorithm for it? Now algorithm is as follows. See, step 1, input a number and store it to num. Input a number and store it num. Then step 2, compute num into num and store it in square. Now what is num? Num is nothing but it will be taken as a variable name. Num, the abbreviation part of number. Okay, so num is nothing but a variable to be used later in the programming part. Now print square. So there will be three steps in this algorithm. So it is precise and also finite. The good characteristics are here. We will go through again. Uniqueness, finiteness, input output will be here. It is also finite because the steps here will be only three, and precision, the steps are precisely stated or defined. All the steps are precisely stated here. And uniqueness, results of each step are uniquely defined and only depend on the input and the result of the preceding steps, right? So here it will be. The algorithm to find square of a number can be represented pictorially. Now, this thing is known as algorithm, where only steps are written in English. just in plain English in the plain paper. And then the algorithm, this algorithm, when it's stated in this picture pictorially using a flowchart, pictorially representing the algorithm to find square of a number can be represented pictorially using a flowchart shown in the following figure. And this is the figure here. uh, we have already learned about this thing, shapes or symbols to draw flowchart. Now the oval shape is used for terminator, the starting point, and the this is the starting point, and this is the end point, right? Just wait for a moment. This is the starting point, and this is the end point. Start and stop, start and stop. Just wait for a moment. We are here to learn about the algorithm. Start and stop, right? Both are oval shape, start and stop. And here, all these things are here: input, square, and print square. So, this is input section, input num, square means num into num, square means num into num, and then print square. And after that, we will be stop here. Okay, so flowchart to calculate square of a number is drawn here. Now draw a flowchart to solve problem of a non-functioning light bulb. We will discuss it in the next class. I think up to this one it's clearly understood by you. Thank you. If you have any query or doubts, please ask me, and I will definitely answer your doubts. Okay, so for today's class this is enough, and I think you have already make out all the meaning of this program. And algorithm part, what is an algorithm, why do we need an algorithm, how to write down algorithm, characteristics of a good algorithm, and representation of algorithm. Two ways are here, one is flowchart and another is pseudocode. One flowchart and visual representation of flowchart is for an algorithm is discussed properly, and here is an example also. Okay, thank you. And please subscribe my channel, those who are new, please subscribe my channel. I think if it is helpful for you, then whenever I will upload any new videos, it will be accessible for you. Okay, thank you.